Quantum computing is a way of tackling a computational problem where you use different kinds of bits that are called qubits. And these bits qubits behave in a quite different way than a normal classical bit in a normal classical computer. That means that you have to completely reinvent the way you approach a problem, write the algorithms, write the software, make the hardware and everything. So a quantum computer is fundamentally different from a classical computer. But that being said, there are still some things that a quantum computer will never replace a classical computer of doing. So eventually in 10 to 20 years, I imagine that we have the quantum computer unit as a part of a computing ecosystem where you have different types of CPUs and GPUs and TPUs, and then the QPU will then eventually solve a specific part of the problem.
So the big challenge in quantum computing is really a hardware challenge. Can we build these quantum computers at all? Do we have the material science capabilities of growing quantum systems so large that is required for full-blown quantum computing? So I think it's really about whether humankind is capable of building these machines. Just like when you were anticipating should humankind go to the moon, could we actually do it? Are we capable of building a rocket that can take you to the moon? I think it's the same kind of exercise here. Can we build a quantum computer? We'll have to really push technology forward and forward to see if we are able to do that.
Also a tough question. So at our company, we work with classical algorithms. We think and believe, and we know also that classical algorithms will never go away. What we do with quantum computers is we look at the mathematics behind the problems we are trying to solve, and really only the hard parts, which are really hard to solve and you can't even solve with a classical computer, we are trying to solve with a quantum computer. But this will also take time, as research just takes time over years, over decades. But we believe that quantum computers will be at some point ready where we really can make use of classical and quantum computers in combination to solve very important problems in the future.
I think the main advancements are really being able to handle these noisy quantum computers and quantum devices, and therefore to find ways to understand how to deal with the very subject to errors data. Quantum mechanics is a probabilistic theory, so what this means basically is that in the end what we do is that we do measurements, we obtain data, and we have to extract information from this data. And when we redo the experiment again, we do another measurement, we will obtain different sets of data, and we have to collect many, create statistics. It's very tricky, it's very exciting, and especially it's difficult when it is when these devices are subjected to so much noise. So this is a great challenge. But on the other hand, well, for every great challenge there is a great opportunity. So I think that solving these problems for sure will also lead us to a breakthrough that is of very fundamental nature in science. So we will learn something very important for quantum mechanics itself as we proceed in trying to handle more practical problems like noise in quantum devices. I am completely convinced of this, and this is actually one of the reasons why for me it's so exciting, besides the practical applications.
I don't know. I'm not a politician. I'm non-partisan. But I'm in favor of democratizing technology. I believe technology and its democratization is gonna empower us, empower societies, and it will also create more global security. I don't think quantum computers will be similar to general purpose computers that we have today, but I think there's some extent of democratization is necessary.
Well, quantum economy, I don't think we will get a quantum economy. Quantum computers or quantum technology will augment society as we see it. What we will, there won't be a sort of a disruptive thing from an economical side or from a finance side. We will see this tool being implemented in a number of industries. They will benefit from it. Better products will come out, cheaper products, new products, and it'll all benefit society in one way or another. So we will slowly progress towards, in general, a better society, a better economy. So if we want to prepare for a quantum economy, I think it's just a question of understanding where this technology can be used. There are areas that are that this technology is more easily adapted to, chemistry being one of them. There are others that are further away, but will eventually come within reach and improve those areas. So my general suggestion would be that understand the technology, understand how to impact society, and the quantum economy, as you say it, will sort of be a side effect of it.